In this video, I will demonstrate how to perform a Kruskal-Wallis test. This test is the non-parametric alternative to a one-way ANOVA, and in this case, we're going to be comparing multiple groups of individuals based upon how they ranked the importance of sleep. And so the highest possible rank it could be was ranking it very important, and the lowest would be unimportant. And we've got our participants broken up by the number of hours they typically train within their sport. And we've got three categories there, less than 10 hours, 11 to 20 hours, and then 21 to 30 hours. And so we want to compare the difference, the potential difference between the number of hours somebody trains and how important they rank sleep. And so our null hypothesis would be that there would be no difference in the median rank among our three groups or between our three groups. And so we're going to test that null hypothesis. So not unlike what we would do in a one-way ANOVA, but in this case, our outcome is not numeric, it's ordinal in nature, or it could be skewed numeric if we had that situation. So in order to run this particular analysis, we go to the analysis menu, choose non-parametrics, and then choose the Kruskal-Wallis test. So our first thing we have to do is choose our dependent variable. In this case, it is sleep rank. Click confirm. And our independent variable, as we mentioned, is going to be the number of hours that they train. And again, we've got three categories there. So we click training and confirm. And once we have those two variables in place, we go ahead and click calculate. And so we're going to look at the raw output first. And so it's pretty minimal, pretty bare bones. And so the first thing we can see here is what would be considered kind of the typical rank for each of the three groups. So the 20 to 30 hour group, their typical rank is somewhere up higher towards the top, towards the higher ranking, so closer to very important. The 11 to 20 hours is kind of in the middle, and the less than 10 hours is down near the bottom. And so what we're interested in here is determining if this difference that we're seeing as far as the typical rank for each group is significantly different. We've got our chi-square value here, and we have our p-value. So we can see here our p-value is less than 0.05, so we know there is a significant difference among these three groups somewhere. And so that, not unlike the omnibus test in a one-way ANOVA, we now know, because we have significance here, that we will then have to do post hoc tests or pairwise comparisons to compare each of the pairs of groups up to each other to see where that difference actually lies. And so the table just below shows our post hoc tests, and we can see each pair of groups, so the less than 10 hour group compared to the 11 to 20 hour group, 10 hour group compared to the 21 to 30 hour group, and so on. And so what we're going to be doing here is comparing an observed difference to a critical value. So if the observed difference exceeds the critical value, then that would mean that there is a significant difference between those two groups. So if we look at our first pair here, you can see the less than 10 to 11 to 20 hour group, their observed difference was 3.5 and a critical value of 8.2. So that 3.5 is less than 8.2. So those two groups are not different than one another. And then we can do the same thing with the remaining two pairs, and we can see that the only pair that has an observed difference greater than the critical value is the less than 10 hour and the 21 to 30 hour group. So those two groups are statistically significant in their difference in how they're ranking the importance of sleep, which makes sense if we go back to our typical rank here. The first table, we can see a typical rank in the 21 to 30 hour group is 4, and the typical rank for less than 10 hours is 18. So there's definitely a difference there, and that difference is statistically significant. The other pairs of groups are not statistically significant in their differences. So we can visualize this a little bit more if we go to the interpreted output, and we can see the box plots that demonstrate the typical rank for each group. So we can see here the 21 to 30 hour group is down here, which means they're typically ranking themselves higher, more importance. Sleep has more importance. compared to the thick line of the 11 to 20 hour group, and then of course the thick line of the less than 10 hour group, so we can see that separation between them. So from this, at this point, after performing this Kruskal-Wallis test, we can conclude that there are significant differences between the three groups based upon sleep importance rank. But there's only one pair that shows a significant difference, and that's the less than 10 hour group and the 21 to 30 hour group. So we can conclude that the number of hours that you train does seem to have an effect on how you rank the importance of sleep, being if you train the fewest hours or the most hours, that seems to be the level of training that creates the biggest difference in how you rank the importance of sleep. Comparing kind of that middle training level to the lower to the upper, not a significant difference. But comparing the fewest hours to the most hours, there does appear to be a significant effect on your sleep importance rank. So hopefully that this video has been useful for you, and good luck using this in your own research.